everyone, I'm Ben. As he said, I'm co-creator and engineer behind Halide, Kino, and some other popular photo and video apps. And I am giving this talk because I love talking about video and photography, and this topic excites me. But also the reason I'm giving this talk is because you've probably noticed in the last few years companies talking more and more about HDR technology. And if you've ever tried to dive into Apple's documentation and this is your first exposure to these technologies, it can be extremely intimidating. And I wanted to give a talk that doesn't just go over the sample code that Apple provided, but take a step back and dive into some of the fundamental concepts to build the right mental model and make it easier when you go in there and try building this type of stuff yourself. And also to excite you about this technology, because I think that everyone should care about HDR, because this is an amazing transition in video and photography technology. It's comparable to the move from CRTs and analog and HDTV to HDR or HDTV and modern displays. Not to be dramatic, but it could be like the difference between black and white and color television. It's that dramatic. And if you have heard about HDR before, the idea that this is about display technology might be a little confusing, because I'm sure a lot of you first heard about HDR maybe 15 years ago, or maybe I'm just old, with the introduction to HDR mode on the iPhone in 2010. And this is a major source of confusion for a lot of people when we talk about HDR. In fact, when we introduced some of the HDR features we're going to be launching this year to our users, at first they thought we were talking about this separate HDR mode stuff, and I want to take a moment to just clear up what that is and what HDR displays are and how the two are different. Now, HDR as HDR mode, before computational photography, well, it was impossible to capture these brilliant sunsets. For those of you who've tried to use non-smartphone cameras, you would fiddle around with these settings, and no matter what you did, it was either too dark or too bright. And so this algorithm was introduced that would take these different exposures and sort of fuse them together through magic. We'll talk a little bit more about that later. But what's important also, by the way, to note is that we're not using Apple's HDR algorithm here. We've been developing one of our own for Halide, but whether you're talking about this or what Google does or what Apple does, they all kind of operate the same way with modifying the original values so they can just be displayed properly on screens. And it's worth pointing out that this is actually not HDR. It would be more accurate to call these types of images, while they might be stunning, fake HDR. And we'll get back to that in a minute. So just for now, please pretend that this is your first time hearing the term HDR. And just let's start fresh. HDR is a new display technology that creates more vivid and realistic images. In fact, this technology is so new that it's hard to give a presentation about it. This projector either isn't capable of or isn't configured for HDR. If you're viewing this at home, I doubt the video is going to be mastered for HDR. But if everyone here has an iPhone, you've been exposed to HDR photos every day, because for several years now, Apple's first-party camera and the Photos app has actually been rendering photos in HDR. And it's the reason that the photos seem strangely more realistic and beautiful compared to yesteryear. And the reason that we've decided to invest in this technology, building a camera app, is because our users who are now accustomed to these images, going back to standard dynamic range photos feels like a step backwards, something feels off. And this is also relevant to you, because other companies, such as Instagram, are now adopting HDR uploads. And in fact, finally, Safari's developer preview has now merged in HDR photography support. So this is probably the year that we're going to be seeing a lot more talk about HDR at WWDC, and it could quickly accelerate the adoption. Now, there are three reasons that you want to care about this technology. I've already talked about if you don't, then you might be getting bug reports from users about why don't my photos look right? There's also practical reasons. I came across this cool open source library someone built that renders QR codes using the maximum brightness level of your display, which makes it easier for QR code readers to pick them up. But you could also do it just for pizzazz, just for creativity. If you look closely at the new Siri effect when you trigger Siri, it draws this clearly HDR border that pops from the display to really show emphasis. Okay, so I've talked about this stuff at a high level. I've just said more vivid and realistic images, but what is high dynamic range? Let's set aside the word high and focus on dynamic range, okay? Every display, whether it's this projector, monitor, or the screen in your pocket, is capable of a maximum white level and a minimum black level. Okay, so we'll just say this projector is capable of outputting 200 nits. You might have heard nits as a unit of measurement. Apple uses it in marketing to sell their new phones. So white could be 200 nits, and then black could be 1 nit. In a traditional display, you can't display true black. Even if you turn up or down the brightness, there's always a little bit of light leaking through. So within this range, we'll say that the contrast ratio, the difference between the darkest black and the brightest white, is 200 to 1. It's pretty standard. The problem is, in the real world, if you were to take a light meter and point it at the clouds in the sky and measure that reading and compare it to the light coming out of the buildings in shadow, you could be seeing thousands of times more light coming from the clouds, or tens of thousands more times light. And when you were talking about that high of a ratio from dark to light, well, if you try to squeeze it onto a display that can't show that much contrast, then something has to go, whether it's the highlights or the shadows. And dynamic range isn't this new concept in computers. It actually predates screens altogether, because photographers have had to deal with low dynamic range in the form of paper. Paper has even less dynamic range than the worst screens. And yet, photographers were able to represent high dynamic range scenes like these brilliant landscapes on paper. In this example from the American photographer Ansel Adams, the way that they accomplished this was, and this is a fun fact, our cameras today and traditional analog cameras can actually capture all of these values. This wide dynamic range from the darkest of shadow to brightest of light, not as much as the human eye, but cameras are capable of capturing it. But the problem is displaying it. So in the case of paper, during the process of transferring from a negative to a print, the artist would momentarily block parts of the paper to prevent them from being blown out or expose certain areas to more light. So it would be pushing and pulling values to fit within the dynamic range. And then in the 90s, it became more of an issue as, again, cameras were getting better and we were facing this problem in the age of computers. And they moved over to algorithms that would accomplish the same effect with a little more automation. You wouldn't be standing in front of the paper waving a disk, right? And so researchers came up with a system that they called, instead of dodging and burning, tone mapping, which sounds kind of technical. It doesn't really sell phones. So when our smartphones began to be capable of accomplishing the same kind of technical feat, the marketing departments of these companies said, let's call it HDR mode. And unfortunately, that stuck. So that brings us to HDR as a display. So HDR is a new screen technology, but I want to put new in quotes, because in fact, a lot of these technologies started showing up 10 years ago. And they are in the form of OLEDs, micro LEDs. These devices are capable of generating much more bright images, which in turn means higher dynamic range. Not as bright as real life. You wouldn't want a device that would blind you with the light of the sun. But because it can display more dynamic range, there's less of a need for tone mapping except in more extreme situations. And then if you do need to perform tone mapping, it doesn't need to push and pull values so much that create the unrealistic images that a lot of people criticize when they talk about smart HDR. It's just asking these algorithms to do too much work. So that's all to say that these devices are capable of higher dynamic range, but not as much as the human visual system. So hopefully I've gotten you excited about this, and you're wondering, okay, what do I have to do to support this? Do I need to go take a grad school class on computer imaging? Now, luckily, Apple handles a lot of this automatically in its frameworks. So I'm not going to, again, dive deep into the sample code. There's plenty of it on the Apple developer website, but I'm going to hit on some of the high-level concepts. And one of the important things to know is that it's much easier this year compared to previous years because Apple has adopted the same HDR system that was originally pioneered by Adobe, and they call it adaptive HDR. Now, in the past, if you wanted to support HDR photos, you really had to encode them as HEIC files. Unfortunately, if anyone here has tried to ever upload an HEIC file to a web server, you know that the support outside of the Apple ecosystem isn't all that great. Luckily, through adaptive HDR, you don't need to encode them as HEICs anymore. In fact, you can store them in JPEGs. The magic that they did to accomplish this is that they now store the necessary HDR metadata inside the EXIF data, a separate image, really a gain map, that can be applied to a standard dynamic range image to generate the HDR version of it. So what that means is, for apps that don't know how to read HDR in JPEGs, or for browsers that don't know how to, they just pick up this SDR version, and then if you're using a framework or a system that knows how to look for the gain map, it'll just work automatically. And the important thing for you to understand if you're using these frameworks, though, is that most web services that I know of strip out EXIF data for good reason. They're concerned about privacy and leaking GPS tags, et cetera. But you have to be more conscientious about what you're stripping out. And for many people in this room, it means having a conversation with your back-end engineers to make sure that they're not muddling with that data. And also making sure that you're using a framework if you're resizing images or cropping images that are aware of this extra data and handling it properly. Based on what I've looked into with open source and submitting a bug report to our CMS Ghost, we still have a little ways to go. So certainly I'm sure open source contributions will be welcome on the back end there. But what if you want to draw HDR in your app, to build your own Siri effect in your UI? Well, the good news there is that Apple has created an abstraction so that most people don't have to worry about HDR. You just operate in the same 0 to 1 range of values and just draw your apps as you did before. But if you want to tap into that extra brightness value, you can now request values greater than 1. You could draw a circle with a value of 2, and it will effectively be twice as bright as the SDR version of white would have been. This is called Extended Dynamic Range, or EDR. Now, I will give you a word of warning before we dig too much into this. When it comes to user interfaces, HDR is a spice. A little bit goes a long way. If you want to unlock this and you are working with metal, and that's what we're doing in Halide, in our image lab, we draw everything with metal and core image. You just have to opt in by setting a property saying wants extended dynamic range content, and then making sure that you're working with a color space that is aware of extended dynamic range. Apple introduced a number of color spaces that are prefixed extended, so extended display P3. And then you need to make sure you're working with float values, which sounds like a lot of steps, but if you're a graphics programmer, it's like 5 minutes worth of fiddling with knobs. But this is what's really interesting, is while preparing for this talk, I was curious. It wasn't documented, but at some point, you became able to do this in Swift UI. Like, I just tried it this afternoon. I did a build. I don't know if this was slipped into iOS 18 or perhaps it's accidentally working and could break in an iOS update. This is the joy of working in Swift. All of these surprises. So don't rely too much on it. But again, this is relevant because you should really not be using HDR for important UI. You should not use HDR for UI. I knew I had to include one reference to Neon Genesis Evangelion. And one of the reasons that you're going to run into a problem if you use it too much is that the way that the human visual system works. Let's say you have this bright idea of like, I really want my text labels to stand out, or I want to have a bright HDR white background, is that our eyes will adapt. So all of iOS draws its UI in SDR because it's, for long periods of time, more convenient to look at. But if you start adding in major elements that are in HDR, suddenly the previous white bits look gray by comparison because our brains are magnificent machines that will magically compensate. So again, just be very careful. The other reason, even if you think you know more than me, is that HDR will often be limited even on the same device. So it would make sense, let's say that you plug your iPhone into a dock and the TV doesn't support HDR, it doesn't render, right? But in fact, the screen can lose HDR capability. For example, if you are in bright sunlight and the adaptive sensor sees that it needs to boost up its brightness level, it will eat into the HDR values to do it, and suddenly there's no difference between HDR white and SDR white. Also, the user could enable low power mode, and obviously a brighter light consumes more energy, so you lose HDR. The good news is, in these circumstances, Apple's frameworks will try to tone map photos that are using their frameworks automatically. So if you have an HDR photo in a UI image view or a Swift view, it will try to tone map it for you, but you will lose contrast, but it'll still be there. In newer versions of iOS, it won't clip, which is uglier. And also, if you want to, there are ways in the framework to write your own dynamic tone mapping. But you should never rely on HDR or make assumptions about what values are available. So the way that you check for availability is a property called current EDR headroom on UI screen. I don't think that there's an affordance in Swift UI. Maybe that's why they don't want to talk about it yet. And even weirder, there's no way to subscribe to notifications when the headroom changes. So if you're writing an app that has a run loop where you're regularly redrawing the screen, you just query it on every redraw. In my case, I had just had to write a polling system that every second or so checks, and if headroom changes, then I re-render appropriately. Now, one last thing, I could probably fill hours of time talking about color spaces, but briefly I will touch on, usually HDR is accompanied by wide color gamut. And really briefly, a color space and a gamut talks about the range of colors that your device is capable of representing. For several decades, sRGB was the color space. It was the default color space if you didn't tag images on the web, and display technology has come a long way in several decades. So along with the industry standardizing on HDR, they've also standardized on a wide color gamut. What that means is that you are not appropriately tagging images, or if someone uploads an image and someone's like, we could save space by stripping out that color metadata, well, it will try to render your wide gamut image in a lower gamut, which will make everything look muted and desaturated. So that's all to say, you are going to want to audit your color management pipeline. Make sure you're not stripping this color tags. Otherwise, yes, you'll have more brightness values, but overall, the image will seem like duller. And finally, to summarize, you're going to want to have difficult conversations with your back-end engineers about how to properly handle HDR gain maps. If you are currently clamping values between 0 and 1, you're going to want to cut that out unless you want to turn off HDR. You'll want to audit your color management and check for headroom, and always have an appropriate fallback. So for example, this photo I took of the Silver Temple, which was rendered with Halide's new HDR mode. This uses adaptive HDR, and while it would be nice to see all of the details in the clouds, we rendered a version that falls back pretty decently in showing all of the content compared to if we'd gone just pure HDR all in. And so that is all the time that I have available to talk about this really fascinating topic, and I will be available outside office hours to answer any questions or just talk about photography. Yeah, thanks.